Hey guys, this is Andre here, and today we have the second episode of competitive programming. Hopefully, this is helping you guys understand how I solve some of these problems. Some of these are very simple problems, and it doesn't take too long to solve. But as they get more complex, I think it will be very useful how to see how an experienced software developer goes about solving this. So yeah, let me know. So what we have here is called maximum draw. It's the next problem, and so it's you're getting ready to go to work and you need to grab socks. It's very important to be well dressed. You don't want to be a schmuck, right? There's n colors of socks in the drawer, and as always, I'll have the link to the problems in the description as well as my GitHub. Um, how many socks need to be removed so that you have a matching pair? So we have to guarantee a matching pair. So immediately when you read this, you should be thinking about worst case scenario. That's what this question is asking about. So let's think about this. If there's two colors of socks in the drawer, how many? So you have red and blue socks, and you remove two socks twice. The best case scenario is two socks have the same color, but we need to have a guarantee, and we can only guarantee in the worst case scenario. So that means that our first draw is going to be red, our second draw is going to be blue. So we need to draw again, and because there's only two colors, it will for sure be red or blue, and we'll have a pair. If we have one color of socks and we draw twice, it's guaranteed to be a pair. Okay, so what if we have three colors of socks, red, blue, and green? Well, then we need to draw three times, for red, blue, and green, and then draw an additional time to get either red, blue, or green and complete the pair. So when we have this function, it's just reading the input. The input is going to look like the number of test cases and the number of socks per line. So a little different than the last question. So let's just write it out. One pair of socks, draw twice. Two pairs of socks, we need to draw three times, right? Red, blue, and then red or blue. Three pairs of socks, we need to draw four times. So red, blue, and green, and then red, blue, or green on the fourth draw. So as we can see, it's we're really just returning the number of socks plus one, right? Because if we have three colors of socks, we need to draw three times plus an additional time. Four colors of socks, we need to draw four times plus an additional time. So we just return n plus one. We run the code against the test cases, and then submit. Let's see how we did. Boom. Alright, finished. And now I should prompt us to the next challenge. Okay, minimum height triangle. So we have integers b and a. So b is the base, a is the area. Find the smallest integers h such that there exists a triangle of height h and base b, having an area of at least a. At least a. That means we need to round up. At least a. It can be higher than a, but it can't be lower. And because it's integers, okay, I see. So in this example, our base is 4, our area is 6, so what should the height be? The formula for height of a triangle, hopefully everyone knows this if you went to school. Area equals 1/2 times base times height. So our base is 4 divided by 2, right? For the half, it's 2 times our height of 3 would equal 6. So this makes sense. And then you can see the points but this is actually extra information. We don't care about this. So for every input line, you see now they don't give us the number of test cases, but for every input line, we just get the values and we need to read them and output the height. So okay, we have another example here. So let's see. You can see the function now looks a little differently because we're not looping over test cases, we're just getting lines until there's nothing left in the file. So okay, no, that's just quite simple. So the area equals to 1/2 times base times height. Height is equal to 2 times area divided by b. So integer h is equal to 2 times area divided by, it is called area divided by triangle base. Now this will give us, if the numbers match up, this will always work, and I will show you. I don't think this is going to work for all test cases. As a matter of fact, it will not. But if we run right now, compilation error. That is because we are not returning H. My bad. We run now. It should pass basic test cases. But you see, if the values are like 17 and 100, our output is expected to be 12, which means we may have to round up, and we are probably rounding down. So let's do a C. So this will round up to the nearest integer. So the issue is that we actually want to make this a float division. There we go. We add a float, so this becomes a float, and we can round up. And now if we run through the sample test cases that they provided, we should get the correct answer. And now let's submit the code. And we passed all of them. And see, we are at the 6-minute mark, so we can probably do an additional example. Let's wait for a sec. There we go, Handshake. Let's start this bad boy. And okay, so let's see. The annual meeting of board directors is happening, and you need to shake hands with exactly one time with every other attendee. How many handshakes are there? So exactly one time. That means they're unique. So if there's one attendee, how many hands do you shake? 0. If there's 2 attendees, there's one unique handshake, right? So what about 3 attendees? So person 1 will shake hands with person 2 and 3, so that's 2 handshakes. And person 2 will shake hands with person 3, so that's another, so 3 handshakes. Okay, so they give us the number of test cases, the input, so let's just go through this. It's always visualize it. If you can understand it, you can visualize it, you can solve it. So 1 person, 0 handshakes. 2 people, 1 handshake. 3 people, as we can see, this is not growing linearly. 3 people is going to be person 1 shakes hands with 2 and 3, and person 2 with 3, so 3 handshakes. 4 people is going to be person 1 with 2, 3, and 4, so we have 3, and then the next iteration is going to be person 2 shakes hands with 2 and 3, so we have 2, so that's 5, and then person 3 with 4, so it's going to be 6. So as we can see, we're kind of iterating through the people, which means we're going to have a loop. So integer handshakes equals 0, we return handshakes, boom. So let's loop for integer I is equal to, and we want to loop here 0 times, here once, here 3 times, 2 times, and then here 3 times. So our n is the number of people, so if we have 4 people, we loop 3 times, 3 people loop 2 times, so we actually loop n minus 1 times. Well, n is greater than 0, I minus, so we're looping in reverse. And we can say handshakes equals, so what should we add? Let's think about this. Not equals, but plus equals. Here we have 2 people. We loop once and we add 1. Here we have 3 people. We loop twice the first time. Person 1 shakes hands with person 2 and 3, so we add 2. The second time, person 2 shakes hands with person 3, so we add 1. And then in here we add person 1 will shake hands with 2, 3, and 4, and then so we have 3, and then 3 is gonna shake, or 2 is gonna, person 2 is gonna shake hands with 2 and 3, so we have 2, and then person 3 with 4, so we have 3, 2, 1. So we're actually looping 3 times, and we have 3, 2, 1. So we're just gonna be adding I, which is decreasing every loop by 1. So in this case, the first time it would be 3, then 2, then 1. And let's see, we return handshakes and we run the code. Boom. And we submit the code. If you want, I can explain the helper functions they give us more thoroughly, but for now they're not needed. And yeah, so there we go, the next challenge button. See, I don't know what happened, it bugged out. But I think this is good for now. I don't want to make the videos too long. These ones are pretty simple, but if they help or they're useful, please let me know. And I hope you had a great time. Stay tuned for more.